welcome to Koi. Uh, so we're recording our first episode here, and from a series that will eventually uh, invite several other researchers who would present you their research about the changing planet. So starting off, I'd like to sort of give an introduction about what the channel is about. So basically, Koi means where in Bangla, and the motivation behind this channel is that we will try to answer the vital questions of our changing planet using geospatial technologies. We're going to try to bring to you the latest state of the art of what's happening in terms of remote sensing and GIS technologies, and also in general how the climate research is evolving. So one other major aspects of this channel is like we are trying to promote early career researchers. We understand that early career researchers, particularly master's, PhD, and postdoc students, are sort of the ones who sort of execute a lot of these vital research. And it's the whole philosophy behind COI is that we want to provide the early career researchers with a platform to present their research. So moving on, just introducing myself, I'm Monojit Shaha. I'm a PhD student at the University of Maryland, and I'm also a graduate research assistant at the Cryospheric Sciences Laboratory at NASA Goddard Space Flight Center. So today we have with us a very special guest. We have Samrin Sumaiya Sauda. So Sauda is a PhD student at Penn State University, and she studies compound flooding, and she studies it uh, with a mix of technologies, but also incorporating geospatial technologies as well. So moving on, just giving a brief intro of why compound flooding is important and why we sort of chose this topic today is that flooding has been identified as one of the major indicators of climate change. And a recent research, which was just published from the American Meteorological Society, showed that compound flooding events, such as the one that occurred during Hurricane Sandy, uh, would increase by at least 5 times by the end of the century. So we do understand the importance and gravity of this topic and why it is very important for research to continue in this field. So moving on, first of all, thank you, Sauda, for joining our podcast. Uh, and just starting off, it would be great if you can sort of introduce yourself. How did you get into into this field of like studying compound disasters?
Thank you, Manjit. Thank you for having me here. Hi all. This is Sauda, and I'm currently a PhD student in geography at Penn State. I've completed my master's in geography from Virginia Tech, and also I have completed my undergrad degree in geography and environment at the University of Dhaka in Bangladesh. So I think I have been a geographer all my life. And my research focuses on basically GIS science, remote sensing, deep learning, integrating those approaches and being applied to extreme weather and hydroclimate phenomena.
Right. Yeah. Thank you, Sauda. That was a really great introduction, and it was great that you introduced yourself as a geographer, and I like to do that myself. I almost have the similar background as she does. We come from the same undergrad university in Bangladesh. So
Right.
yeah. So yeah, I'm so happy to have a fellow geographer in this channel. And yeah. So basically, moving on, we'd like to know a lot more about the research, the fascinating research that you're doing. Uh, so yeah, tell us something about what are compound floods? What's compound? So yeah.
Um, so I think compound floods in general would be like it happens when two or more flood drivers happen together or in close succession. This could be either physical forces such as sea level rise, heavy precipitation, high river flow, happening together or in close succession. But this can also be like anthropogenic forces such as like levee or dam failure. And Basically, for my PhD, I'm trying to understand like the primary drivers and processes that determine the spatiotemporal trends of compound coastal floods, especially in the US. And another aspect of my research is also like trying to integrate AI, like specifically deep learning, to improve the understanding and prediction of this kind of complex floods.
Right, absolutely. I know that your focus is largely the U.S. And the increase in compound flooding in the U.S. particularly. In the recent times, we have seen major hurricanes. Starting off from the Hurricane Sandy that I sort of quoted starting forth, but even recently, we are seeing a surge in compound disasters in the U.S. So, how does it look like? How does it look in terms of the U.S. in your research?
So you mean like what's the situation in the US? Is that
Right,
what you're
exactly. Yeah. So what's the current
okay?
situation, or where are the compound floods in the US?
So I actually have prepared few slides for this podcast, which kind of also maps this kind of compound flood risk uh, for the contiguous US. And maybe once I get to show you all, I hope this will kind of answer your question. But definitely, most of the studies that's happening in the US and also for like worldwide, most of the studies predict that this kind of compound flood events will increase over time because of global warming and other factors like increasing urbanization, sea level rise. So that's actually like bad news for all of us, and we should be prepared.
Right, yeah. You can go ahead and tell us a bit more about your research, like but what are the techniques and you're using, or what is your current focus? Yeah.
Okay, so I'm gonna share my screen. Can you see it? Okay. So before I start talking about just compound floods or some of the latest research or updates, I kind of also wanted to go a little bit broad because when I started working with the compound floods or compound hazard, these were all new concepts for me as well, like new terms. Um, so let's start. Like, imagine hurricanes that, as you already mentioned, imagine hurricanes that happened this year, like Hurricane Helen, Hurricane Milton in the Southeast United States. Together, they brought unprecedented flooding in both the inland and coastal regions and caused like massive destruction. These are like estimated close to $100 billion. Like just imagine two hurricane-induced flood that has already caused such a massive amount of havoc. And it was not just the heavy rainfall that this hurricanes brought, but there were also like the combination of storm surge, heavy wind, and intense rainfall happening at the same time, which led to this like deadly impact. And unfortunately, there will be more in the future. That's what most studies suggest. And This kind of hazards are like examples of multi-hazard event. So compound hazard is actually a part of a type of multi-hazard events, but there are actually like two more type of multi-hazard events that I thought I would share here. So basically, there are different way you can classify a multi-hazard event, but especially for those in the context of social vulnerability approach, they basically classify this multi-hazard event into three types. We have the aggregate, cascading, and then the compound hazards. The first one, which is the aggregate classification, it basically describes the accumulation of impacts from multiple independent events. Some of these events can be unrelated, but they're maybe occurring sequentially at the same location. Imagine having multiple hurricane landfalls maybe in the same time of the year. Sometimes these events are related, but maybe happening in different locations. For example, simultaneous droughts happening in different grain producing areas in the world. Uh, then we have the second type, which is the cascading classification. This is basically events where one hazard triggers other events. For example, Hurricane Harvey, which happened in 2016, I believe, they produced inland flooding, which then caused a massive chemical plant explosion and fire. Um, in Houston, Texas. So that's like an example of a cascading hazard. And then the last, we have the compound hazard, which is, as I've mentioned earlier, the combination of two or more weather or climate events, not necessarily extreme, but they have to happen at the same time or in close succession or concurrently in different regions, but they can lead to very extreme impacts. And this is like the defining characteristics of compound hazards. And these are conceptually and computationally most difficult to study this kinds of phenomena. So there has been a resurgence in interest of this kind of complex disasters. It's not these are not like very new concepts, but there has been, as I mentioned, like a resurgence in interest because many studies such as that there happens to be more of this large and connected disasters happening frequently, and this can be on the basis of different geophysical or meteorological thresholds. And secondly, because this kind of complex events have the potential to cause massive crisis, widespread disruptions to regional to global economies because of the interconnectedness of production and consumption processes and patterns. So I think I have kind of briefly talked about this kind of complex hazards in the natural hazard framework. And now I will focus more on the compound flood, which is basically what I am working on for my PhD. So compound floods are, for my study, it's basically compound coastal floods. So compound coastal floods happens when two or more flood drivers happen together or in close succession. And it's alarming because according to the IPCC sixth assessment report, the probability of this kind of flood has increased in some locations and will continue to increase, especially because of sea level rise and especially because of change in precipitation intensity associated with tropical cyclones. And there are different kinds of mechanisms that can lead to this kind of compound coastal floods. One of the mechanism which is very common is when there is a low pressure system passing through the coast, for example, when there is a hurricane or maybe a tropical storm, which kind of, increases the sea level rise above the coastal flood threshold. And also they bring like excessive precipitation. So all this happening at the same time and, in the same location can amplify the flood risk and severity in the coastal low-lying areas. There can be also other mechanisms. For example, sometimes when there is a high sea level rise, which can lead to high river flow and impeding, because of backwater effects and impeding a free river flow to sea. And low-lying coastal areas are most affected by those kind of mechanism. So these are some of the studies that has been done in the US and also shows what the compound flood risk has been here. And there has been also similar studies in the Europe, also in the other part of the world. And for example, in Europe, what we have seen is that the probability of this kind of compound flood has increased, especially along the Atlantic coast and then the North Sea. Especially for the Europe, what factors has come up is like the intensification of precipitation extremes and also like sea level rise. But here I would actually talk about the US since my research is also in this area. And there are two of the studies that I have shared, especially from Wall 2015 and Convery 2021. These two papers are kind of my favorite, like my go-to papers, and they, I think they have very like beautifully executed and have shown the compound flood risk along the like the U.S. coastal regions. And I must include that there hasn't been much studies like on quantifying this kind of compound flood risk along the U.S. coast. So this two paper kind of is like, being a very prominent one in that field. So according to both the studies, actually, the Atlantic and the Gulf Coast are most susceptible to compound coastal flood, especially because of frequent hurricanes and increasing sea level rise. Especially so for Wall's 2015 paper, what they saw was places where there has been extreme precipitation and storm surge happening at the same time. So the map in the left kind of shows that. It shows the likelihood of joint occurrences of this storm surge and extreme precipitation phenomena for the contiguous United States. The color represents the number of overlapping years between these two attributes. The darker color kind of shows like increasing overlapping years, which means more risk, whereas the lighter color shows lesser number of overlapping years. And it's kind of prominent, like the northeast Atlantic coast, and then also the southeast Atlantic coast, and there are also few in the southwest Pacific coast. You can see like here the likelihood of storm surge and extreme precipitation events happening are very much high. Then we also have this another paper from Ganbari, which kind of actually sees the extreme river flow and the sea level rise. They kind of sees the um, the combination of the sea level rise and extreme river flow. And this was done by a statistical approach, and they estimated the joint return period of extreme river flow and sea level rise. And they also kind of found something similar, like in the current era, the northeast Atlantic and the western part of the Gulf Coast are experiencing the highest probability of compound coastal flood. They also kind of ran future sea level rise scenarios, and that actually shows that the southeast Atlantic coast will experience the highest amplification in terms of compound coastal floods. I'm not sure if it's very clear in the map, but it's like the 2050. Here it shows the 2050 map, which is showing the results from sea level rise models,
Yeah,
where you can see like the orange location, which is more in the southeastern part of
absolutely.
United
Yeah.
States, is showing like how risk this zone would be in the coming years. So yeah,
I
these
think
are basic.
one point, sorry, I'm sorry I interrupted you, but one point I really had to sort of mention here is that
Mhm,
the correlation between like cities which have, which we typically understand as having very high population, this also seem to be
mhm.
having very high risk factors, which is a potential
True.
concern, right? Like, yeah,
Yes.
like just from the map. Yeah.
Yes, that's a good observation. You're on point. And actually, like 40% of the US population lives in coastal areas, in coastal cities, more specifically. So this is kind of important, how these coastal cities are vulnerable, because I think in the past we were more concentrated on just flood phenomena and how people can save themselves from uh, floods. But now when it's becoming more compounding in nature, this kind of poses more risk, especially to the people in the coastal areas. Yeah, so I think especially with climate change, especially leading to sea level rise, may lead to more and more frequent compound events, which cannot be ignored for, future adaptation responses in coastal regions.
Right. Yeah. So yeah, basically, what I really wanted to reinstate is that we are seeing this recurrence, and the studies clearly show that the frequency and the sort of like the predictions that are being made for from up to 2050 doesn't look that good in terms of the projections. So yeah, would you like to tell us a bit about like what your study is trying to sort of focus on, or like are you focusing on the whole of the United States, or do you have like a particular focus? And also if you can add like what geospatial technologies are you sort of incorporating? I know that you're using machine learning and AI, so I'm pretty sure my listeners would be interested to know more about that.
Approaches for understanding and predicting compound floods. We have the probabilistic or like statistical approach, which relies on data records and statistically determine the likelihood of events. We also have physical modeling approach. Most studies actually use those types of uh, physical models like hydrodynamic or hydrological model to understand the interplay of different drivers within a compound flood settings. However, there are some challenges, especially with physical modeling approach. They are very much like computationally intensive and also expensive, and that's why more and more studies are also kind of leaning towards the data-driven approach, which is the machine learning approach. For my study, the aspect of compound flood that I'm trying to understand is like what are the primary drivers and processes that are determining the spatiotemporal trends of compound coastal flood in the US, and how can we use data-driven approaches to predict a compound coastal flood. So for that, I'm trying to develop a deep learning model, which will be more like a long short-term memory model. And this kind of models are pretty common for flood forecasting because this kind of models are able they can capture the dependencies between different kind of variables, and on the basis of those, they can learn the relationship between different types of variables, and on the basis of that, they're pretty good at predicting the variable. So that's why for my prediction part, I'm kind of leaning on like machine learning, and
Yeah.
also because they're compared to physical models, they're also very much computationally they're computationally less intensive
Right.
and less
And yeah, and
expensive.
I'd like
Yep.
to add, like, for example, you are talking about how you're using the long short-term model to not only like understand the trends, but you're also trying to look into the causative factors, which is vital
Yep.
because sometimes, we can't really get a lot from the trend, but when we look into sort of the associated factors, that's when you sort of try to really get to the core of the issue and what's really causing these
Right.
phenomena. Yeah, so I think
Right.
that's very important in terms of that. Yeah, so yeah, but just moving on for the sake of time.
Hmm.
Uh, so so why, like for example, you started your research from Bangladesh, and then eventually you did a master's, and then you're currently doing your PhD. So, do you have any advice in particular for someone who would be interested in your journey? I understand that you are doing very important research, and so yeah, just in general, do you have any advice for our listeners?
Um, so I think I would like to give some advice, which would be hopefully helpful for any aspiring researchers. And I think things that I am also working on myself that can help me with my career would be to gain hands-on experience, like apply for internships if possible, especially with research institutions, because I think that kind of gives you a lot of hand-on experience and kind of helps you to uh, uh, mitigates the gap between your work and solving real world issues. So that's something I think everyone should try. And also like I think staying updated with the latest developments in your interested field related to Earth observation missions, data analysis techniques, following research journals, attending webinars. I think these are really, really important. And also, one last advice would be to build a strong network. Um, I think it would be a great skill if you can collaborate, work with interdisciplinary teams, engage with community, attending networking events, also like following relevant social media platforms like Twitter, LinkedIn. Sorry, it should be X. So X, LinkedIn. I think these are some of the things that I try to do along with my like daily research and academia part. So yeah, those would be some of the advices
Right.
maybe I
Yeah.
would
Sort
like.
of. I just wanted to echo the importance of networking and that you are, and also staying updated. Like, one of the key ways of staying on top of the research is that if you're aware of it. And yeah, now thanks to the new media and the social media platform, you do have new media platforms such as our channel
Right,
coming up,
right.
which tries to sort of address this gap and trying to make research more accessible to people in general. So yeah, thanks, Sauda. The last question. Where do you see your research going? Is there like a particular direction that you're more interested in, or where do you see your PhD sort of going? I know it's a hard question for. I know I'm a PhD student myself, but if you if
Right.
you have like a short answer, that would be nice.
I think for now, yes, I still don't know, but I think for now my objective is to be a leading researcher in the hydroclimate field, because I think I'm very much drawn to that, and also coming from a country that's also kind of vulnerable to like this kind of hydroclimate hazards. I feel like for now my main goal is to establish myself to have those skill sets so that I can be like a leading researcher in the hydroclimate phenomena and do something for the society through my work, something effective. Yeah.
Yeah, kudos to you. So first of all, I think that's the whole reason of why we're doing this podcast is to bring forth leaders such as Sauda, aspiring leaders who want to like make a difference using their research and trying to make a difference in our changing planet. So we just wanted to reinstate that and trying to I like to encourage our listeners to be more engaged and be and try to pursue the research dreams that you have. uh, so yeah, just wrapping up today, Sauda. First of all, thank you so much for coming on to the platform, sharing your very important research, and yeah, I just want to end it there, and I want to thank my listeners for listening, and I would say that look forward to the next episodes. So yeah, thanks.
Thank